Hi, I'm Jim O'Halek with the Bone Company. Today we're going to talk about tube bending and how to lay out tubing in order for it to fit a fixture. In this case, we're going to work on bending to fit a fixture, and the fixture or the tube is going to look like this. You're going to have two 45-degree bends leading to two 90-degree bends, then down the back side, two more 45-degree bends. This should greatly assist you in practicing and also figuring out how you're going to lay out the tube for a job performance test for the IFPS, both the mechanic and the conductor and connector certifications. So first off, if I want a tube to look like this, I have drawn on the board up here how long these particular legs are going to be to fit a particular fixture. My first leg is going to be a 2-inch leg, followed by a 2-inch kickout. Now this 2-inch offset is going to be, in the end, 2.83 inches. Then it leads to a 3-inch leg length. Then it goes into a 90-degree bend into the board. I don't draw 3D, so this is another look at it from the front. A 90-degree bend going into a 6 3/4 inch leg. After that, I go 90-degree bend, back down, the opposite side, mirror image, 3-inch leg, 2.83 inch leg, and a 2-inch leg, and with the 2-inch offset. Down here is how I'm going to lay this thing out. So on the left-hand side, I bend everything from left to right. That's pretty much how I teach it too, and I've had pretty good results. I'm going to take a piece of tubing, and this is exactly how I'm going to lay it out. So on the left, I mark where the start is. So here you can see I have the Sharpie mark on that. I've already cut and deburred this side of the tubing. Then, using a ferrule, I'm going to make my measurements. So I take a ferrule, I slide the ferrule down. Whenever I'm marking these measurements off, I'm going 360 degrees around the tubing so that no matter where I end up in the bender, no matter what orientation, I see where that mark is. So I don't have to do any extra work on that part. So as far as my first leg, it's going to be the actual leg length. I'm not accounting for any stretch. As I bend the tube, the first 45-degree angle I'm going to bend, I have to account for 1/16 of an inch of stretch. So that 1/16 of an inch of stretch, instead of it being a 2.83 inch leg, I'm going to subtract a 1/16 of an inch, and I'm going to have a 2.77 inch leg. My next 45-degree bend, going into my 3-inch leg, I'm also going to subtract 1/16 of an inch. So that 1/16 of an inch is going to end up with a leg length of 2.94 inches. The 90-degree bend, going into that 6 3/4 inch leg, I'm going to have to count for 7/16 of an inch. Now this 1/16, 7/16, and these angles are in your conductor and connector study manual on page 163. So my leg is going to end up being 6.31, taking away the decimal equivalent of 7/16 of an inch. I have another 90-degree bend coming down the back side of this. So I went to my 3-inch leg, I'm going to a 3-inch leg, so after a 90-degree bend, which I'm bending and I'm accounting for because I'm adding stretch to each leg as it's happening, 7/16 of an inch on this side, so this leg is going to be 2.56 inches. One of the things that I'm seeing a lot with people practicing is that they figure going up and coming down it should be the same, and up here with that 2.94 I only have a 45, but on the way back down I'm coming off of a 90-degree bend, so I have to count for that, so it's 2.56. Then my last two, 45-degree angle, 2.77, just like on the way up. Then on my very last bend, after my very last 45-degree bend, I have 1.94 inches, and then I should have my cut. So I'm not going to actually cut the tube just yet, but I put a mark where I think it should be, just so at the end I can align it with the fixture and make sure it works out fine, square, and all that. I add all of these dimensions up, and I come up with a cut length of 21.29 inches. So you can do this in decimal or you can do this fractionally, depending on how it works out. Over here, for this 2-inch kick out, there's a formula for this, and this is also in your conductor and study manual. So if you want a 2-inch kick out with 45-degree angles, this leg has to be 2.83 inches. So that's just for a 45-degree angle, you're going to have your 2 inches times 1.414, and there's other angles in there. The steeper the angle, the shorter your leg can be. The less steep the angle, the longer that leg's going to be. And it has all of the functions in there to figure that out, depending on how much of a kick out you want and how long you want it to be or how gradual you want it to be. Okay, so now that we've laid that out, we've made our marks on the tubing. Another thing to consider too with the tubing is the stuff that I get in bulk, 20-foot lengths, is lubricated. So if you were to cut a lubricated piece of tube, and I cut these to 23 inches, it's perfect length for practice and for the job performance, you want to clean that up. So I take some type of wipe these things off so I'm not lubricated, because if you are lubricated, you have the potential to slip out of the clamp on the bender, and also when you go to flare, you'll push the tube down through the flare if you don't have it clamped hard enough. And with the lube, you have to have it clamped pretty hard. So right now this is a cleaned up piece of tube all ready to go. My first bend is going to be after this 2-inch section here. It's a 45-degree bend. Now I'm going to actually bend my tube. So I'm starting with the left. I'm working my way from left to right. You can see that I have a big Sharpie mark there where I started, where I've already been cut and deburred. That's ready to flare when I come to the end of this assembly. Stick that in there. So now I line up my zeros, the top and bottom zero. Then I take my mark out to that 45-degree graduation mark, and you can see it's semi-highlighted there. And once again, these go in 15-degree increments, so 15, 30, and 45. So you can see that my mark is on my 45 and my zeros are lined up. My start is down here, and I'm clamped well into the tube bender. Now I'm going to take this zero and match it up with the 45. My first bend. Allow for spring back and look at it, and I pretty much ended up on my 45. Take it out of the bender. Go the opposite direction. And definitely have to keep the big picture on this because you want it to end up right. You don't want to keep going in the same direction with bends or anything like that. You see, you just have to play with this. Get the zeros lined up. 45 out there. And when I'm clamped in, I want it all to match up. Another thing you can do is look down at the tube and you can see that I'm not square / plumb in the bender. So you want to get that as best you can. It's hard to be perfect. Then you're going to take your zero once again down to the 45. Now I want my 90 next. So now my line where I measured on my tube goes out to the L, and that's all under the L is also my 90-degree graduation mark. Right there you can see I'm lined up on the zeros again. This leg is coming straight back at me, as straight as possible. Now I'm going to bring this zero down to 90. Now I have another 90 coming up. I'm going to align it as closely as possible because you want a mirror image coming down the backside. Zeros, 90. I'm going to bring this 0 down to 90. Count for a little bit of spring back. Now 45s. So now be cognizant of 45s. You don't want to actually accidentally put another 90-degree bend in there. So line to the best of your ability. Take your zeros down to 45. Put your last 45 in there. Now we take it out of the bender. We're going to see how it looks on the fixture and make sure that our last, where we thought we should cut, is actually where we should cut. You kind of align it on there. Also, I'd like to see if it's going to be square where I'm going to make my cut. And in this case, you can see that I'm going to want to cut just on this side of my Sharpie mark. So I'm going to take my cutters. These cutters also allow for just a flare removal. They have a notch in them. If you come down to it and the flare gets messed up, you could just cut a flare off and it's not going to hurt you too badly. So you start tensioning this handle to get your cutter blade on that. Then as you turn, you tighten. Now I'm going to deburr the inside and outside of the tube that I just cut. You can tell that this is the side I just cut because that's the side I started with the Sharpie mark. Inside tube deburr. You want to deburr, make it clean so you don't have the possibility of tearing it when you go to flare it. So the next step in our process is to, now that I've deburred inside and outside, I have no burrs on this thing, I'm going to put my nut and ferrule on. Now the important thing here is that you want it to fit this fixture. So you want the threads on your nut to be out. Ferrule's next, the wide side out. On both sides. Now we have our 37-degree flare tool here. It's a rigid. It's made for different types, for filling different types of tube. And right in the middle here is my 3/8" carbon steel tube. That's where I'm going to go with that. And on this side, the post on the back side of this clamp fits into the 3/8" hole, detent, whatever you want to call it, to tighten this up before I actually ratchet this down into the tube to make my flare. So I get about flush at the top of the bender. I like to see a little bit of a bead of it, just so I can tell when I'm going into it. Then I'm going to place this over. There's a notch it should fit into, so then I tighten it up. Make sure I'm good and tight. And I also want to make sure that as I come down to flare, it's actually going into the tube freely at first. Make sure I'm snug. I'm going into the center of the tube. Now I can go with it. .37-degree flare, hydraulic applications. Keep turning until it breaks. See, it broke. Spins freely now. Back it out. So now there's my completed 37-degree flare. My ferrule sits up against it, and I'll make contact for the whole flare. And my nut will also fit up over the ferrule and the flare. So now I have my completed assembly. It all looks about right. Should fit fine. It does. Ferrule's in the right direction, nut's in the right direction, it threads on, and there you go. Okay, now that we've completed our assembly, you know how to do 45s and 90s for a kickout like this. So in the future, just reference your job performance study guides and manufacturer specifications for the proper lengths the legs have to be for the different angles, and how much bend, depending on the bender, that's why I'm saying manufacturer specifications, that you're going to have to account for in making this assembly and making it fit. Thanks for watching the video. Good luck.